Hello everyone, today in this video we will be discussing the system software super important questions for externals 2022. So whatever the questions I have mentioned here, those are the repeated questions, and some of the questions I have marked with star, those are the super important questions. It's repeated more than 5 times. So I assure you that if you study what are the questions I have mentioned here, you can easily score at least 60 to 70 marks. Okay, so without wasting any more time, let's get started. And in this video I will be just discussing the brief overview and the key concepts which are present in the answer. If you want the detailed explanation and answer for any of the questions, it is explained in the theory video of the module 1, 2, 3, 4, 5 for SS. I have already uploaded that, right? So you can refer for the detailed information. Timestamps are given there. And let's get started now with the module wise important questions. So in total you can have at max 25 questions. Okay, I'll be selecting 25 questions at max, and in that super important questions are just 10 to 15 questions. Okay, so if you remove the theory, remove the numerical part also, still you will be remaining with 10 questions which are theory questions, and that's short questions, right? So it will be very helpful for you if you prepare those and then go to the numericals and then remaining 25 questions if you prepare. Okay, so what are the study materials I've used? Those are put in the Google Drive link. In the description box you can find out 6 SEM PDFs. So if you click that, you will have many folders there. In that folders you can easily get the PDFs here. Okay, for 18CS61 you will get these PDFs, and the super important you will get this PDF which I am currently referring. Okay, so that's sufficient for you to study and score well marks. So make sure you watch the video till the end, hit the like button and subscribe to my channel for more videos like this. Okay, so these are the alphabets I have mentioned for the references which I have made for the given notes here, like module 1 notes MEMS and module 1 notes Afnan, module 2 notes MEM, and so on. Okay, so and whichever notes I am referring, that alphabet along with that page number. Okay, page number is given here, so we can go through that notes and go to that page number, so you will get the answer for the particular question. And some questions which I have marked star, those you can never miss at any cost. Okay, so in the module 1, let me give you the brief overview of how many questions are there. There are totally 9 questions in module 1. Okay, so in 9 questions, the super important ones are 4 to 5 questions. Okay, so let's get started and go through briefly what are the key concepts you need to keep in mind before approaching the exam. Okay, so the first question is, what is the difference between system software and application software? See, by the name itself you can understand what is system software. It is inbuilt thing, right? The general, what is the about the system, the different functions in the system, operating system and all, those are the system software. And the application software is the means the things we get from outside, like the external sources, the apps we install, those are the application software. It is general and this is specific application. So for more information you can see the PDF or watch my video which I have uploaded in the for the module 1 SS. Okay, so it was presented page number 9. So let's go to page number 9. So yeah, this is what I'm telling. So my PDFs are these ones which are marked as like this, 18CS61. These are my PDFs, and MEMS PDF I have marked with the module 1, and the PDFs are present here. So go to this PDF and page number 9 it was present. So let's go to page number 9. So this is the differences between system software and application software. Okay, so here you'll get many points, so you have to mention these ones. Moving on, we have the second question, which is explain the SIC XE architecture. This is a super important question. Okay, this is very much repeated one and very important one. In this also few subtopics are asked separately, so this is a never to miss question. Explain in detail SIC XE machine architecture. Don't get confused, SIC machine architecture is different, SIC XE machine architecture is different. So it's presented page number 23. So let's go to page number 23. So these are the key concepts which you need to keep in mind. You have to define what is memory, what is register, data format, instruction format, addressing modes, instruction set, and input and output. If I give you the brief overview, in memory you have to mention how many memory and the bytes are allocated for each thing which is getting used, and what is the different types of register, totally 9 registers, and data formats, integer, float, and boolean value, string, how we are storing that. Instruction format, the different types of instructions which are getting used. Addressing modes, index based, indirect, or program relative or base relative. Instruction set, LD, and read, store, and add, multiply, those things. Input and output, how it's getting fetched. More information can be found here, you can go through it. Okay, moving on to the next question, we have what is the different data structures used in assemblers. Okay, data structures used in assemblers, there are 3 data structures which are used in assemblers. Okay, so it's in page number 57. So what are the 3 data structures which are used in the assemblers is op tab, operation code table, symbol tab, symbol table, and location counter variable logctr. By the name itself you can understand, operation code will store the operation codes, symbol table will store the symbols, location counter will store where the particular location of the program is presented. Okay, so those are the only main things, and around that you have to write some content. Those will be you can get plenty of content from here, you can go through it. Okay, then we have the algorithm for pass 1 and pass 2 of assembler. See, this is very important one. So what is the page number? 78. So algorithm for pass 1 and pass 2 of assembler, so that you can never miss at any cost, especially pass 1 you have to never miss. Okay, so this is the algorithm for pass 1 of assembler. In pass 1 what happens, firstly we'll be assigning the addresses, and after that we'll be getting the size of it, and then we'll be writing in pass 2 the object code. Okay, so these two also I have explained in depth in the theory video, you can go through that, and make sure you memorize this one and write 10 times and keep it in your mind. Just exactly you have to write like this. Okay, exactly you have to write like this, you can easily get 7 to 8 marks. Okay, moving on to the next question, generate the object code for SIC XE program. This is the most repeated question, the question which I am showing in the PDF now. So this is present, the solution is presented page number A100, and the same question also I have explained in the theory video. Make sure you solve that question and know the basic concepts. So I'll be telling you what are the basic concepts you need to keep in mind for solving these type of questions. Firstly, you will be given with these values. Okay, where are these values present? If I show you the question paper, in the question paper these values are present at the bottom part. See, these are the things which they will give you. This is known as mnemonic and the opcode table. Okay, here you will get these things, and 3 rows they will be giving you: sum, start, 0. 3 rows they will be giving you sum, start and 0, so that you have to make a separate table and write these 3 rows: sum, start, 0. The sum column is known as label, start column is known as opcode, and the 0 column is known as the operand. After you have written these 3 things, you have to write the pass 1 address and the pass 2 opcode. In between you can write the length, it's optional. Here you will start from 0 if they don't give any address, as in the question they have not given any starting address, you will write 0. And for each of these opcodes, what is the length of it, that you have to write. For this it is 2, for LDA it is 3, for plus LDB it is 4. Wherever you have plus it will be 4, and for LDA and add TIX, GLT, or most of the things will be 3 only. Only the exception will be in plus, it will be 4, and if it is clear or the assembler directives it will be 2. Okay, that's all what you have to keep in mind. After you have written the length, just the addition thing, you easily know how to do the addition part, right? So 2 will be added here, then 3 will be added here, like that we'll keep on writing in hexadecimal. Take your calculator and add in hexadecimal and write. Don't write by yourself in the mind. Okay, you can make mistakes. Okay, so after you have written this one, this is the pass 1. After that you have to write the object codes. How to write the object code, what are the things you need to keep in mind, that is explained in detail in the module video, so not repeating it here, you can watch in that part. Okay, so this is a very important question. If you are done with theory, make sure you do this one as well, because it's mostly expected one. Okay, moving on, we have the next question, which is write a SIC XE program to copy the string CSE from str1 to str2. It's presented page number 51. See, this program, this type of question is actually not present in syllabus. If I have checked the syllabus, in the syllabus this topic is not included, but still they have asked in the previous year papers, although it was not included. So I suggest you first complete the important topics, then after that if you get time, go for this question. Okay, but it's very simple one, you can easily fetch 6 to 7 marks. So how do we write the SIC XE program? Go to page number 51 here. So in page number 51 they have explained both SIC as well as SIC XE. Actually in page number 51, if I show you, it's just SIC. So I have not I didn't realize that it's SIC, so you have to not write this one, you'll lose marks. Go to page number 37. Okay, go to page number 37. In 37 you will have both SIC as well as SIC XE. Same question, how do you write for SIC XE is LDX hash 0, in X register you are storing 0, in T register you are storing 15, then loop it. Loop what? Load the character X in str1, the first character, then store it in str2, then increment it. TX is for incrementing the T, so T will be incremented, it will become 16. I guess it is 14, I guess. Okay, so it will be becoming 14, and it will again loop until it is 0. It will loop, so all the characters will be passed one by one to str2 from str1, and then will be means that's all what you have to do, right? Just copy it into another string, and str1 is defined as byte, which has the characters. This C is the literal value. Okay, system software is stored in str1, and str2 is the reserved bytes. 15 bytes are reserved for it. Okay, so make sure you write this program 2 to 3 times and keep in your mind. Okay, the last question from module 1, which is list the various machine independent and dependent features. So the mostly repeated is the independent features, and that is nothing but these 5 things: program relocation, control section, program linking, literal expressions, and program blocks. So I have to know what are these things and what are the important key concepts in it. If you know that, it is sufficient for you. You can easily score 7 to 8 marks from that. And machine dependent features, there are just two features. I'll discuss that in few moments. And after that, what we have is the one pass and multipass assemblers. One pass means it will just have one pass. Multipass means it will just have multipass. It will look like very like common sense, like by using the name only we can understand, but actually that's the only thing in that it will be present that only. So if you know the main concept, you can write the content around it, right? So I'll show you briefly what are the key concepts you need to keep in mind. After that, we have what is loader and write the algorithm for the working of single bootstrap loader. So that also is a concept which is not repeated in the previous year papers because it was not present in the syllabus. It was out of the syllabus, but in the 18 scheme it is present. Okay, so I'll give you a brief overview what you need to keep in mind for this one as well. So let's start from the machine independent and dependent features in page number 80 and 120. So let's go to that page number. So machine dependent and independent features. The important one what I told is independent features. So this is the machine dependent features. Just one page we have. You have to just write about the registers, data format, instruction format. There are total 4 types of formats. After that, we have the addressing modes, same as what we had done for the machine architecture, and different addressing modes notations. And these are the addressing modes: piece relative, base relative, extended instruction format, and this much only. Okay, this next topic is starting from here. So this one is machine dependent features. That you have tried this much only. After that comes the machine independent features. Independent features is a quite long topic, but I'll tell you what are the key points to keep in mind. Okay, so here totally 5 independent features are there. The first one is the literals, second is the EQU and ORG, equating and origin, and third one is the expressions, and fourth one is the program blocks, and fifth one is the control sections. So what do you understand by the term literal? Literal means you will be just literally assigning the value like an equal sign. So what you have to write is this only, like the definition of literal, what it means: literally assigning the value. Okay, because they have means written the definition like that only. Okay, such an operation is called literal because the value is stated literally in the instruction. Okay, so this is the definition of it. And then we have the code part. So if you write C and EOF, what will happen is C will be loaded in EOF. Okay, C will be having C is just for the denotation, EOF is the end of the file. Okay, so in ENDFIL, there what we will be storing is EOF. If you don't use literal, we'll be using it will be like this. If you use literal, it will be like this. This is more simple, right? So what's actually happening, let me tell you. See here, first this is getting stored in a byte, then that byte is getting assigned in end fill. But in literal, what we are doing is we're literally assigning this in one line only. In end fill is equal to CEOF. What will happen? It will directly get assigned. Okay, so this is what you have to explain in the literals. And then we have the EQU and ORG. So EQU and ORG is the symbol defining statements. EQU means equate. We can either equate the constant, expression, and previously defined symbol, and ORG is the origin value. Okay, so for the equate and origin, there are a lot of content present here. So make sure you go through it. So ORG, using ORG. So ORG is here. So by using ORG, we can assign a symbol. After going through a function, if you have to come back again, we will be using ORG. So it will be starting from there. Okay, so the definition and the detailed explanation I have already done, so you can go through that. Okay, so that's what these two questions are done, because what we have done is these questions, independent and dependent features. Dependent is just 1.5 page. Independent features nothing but this only. Either they can ask you explain various machine independent features, or they can ask you separately as well. Okay, then we have differentiate between one pass and multipass assembler 166. So let's see what is there. So page number 166. Okay, so this is the page number 166. One pass assembler means there will be just one pass and all the references will be done. And we what we need is we need multipass assembler only when there are references which cannot be passed in one pass. What I mean is, if I show you an example, it will be more clear. See, here we have 3 directives. Okay, so one is reserve word for delta, and delta will be equated to beta, and beta will be equated to alpha. In first iteration only this will happen, in second pass this will happen, in third pass this will happen. That's why for doing this kind of calculation we need multipass assembler. So that's all what you have to write. Write this and explain, it will be sufficient for you. Okay, then we have the last one, which is the loader, about the loader and the algorithm for it. So that's present in my PDF, because the MEMS PDF is the old scheme PDF. in that it was not present. So let's see what is there. That's the last topic. So yeah, here is the thing. What is the loader? Loader means it's a system program that performs the loading function. That is the definition of it. And if you have to give the visual representation, after you generate the object program, that will be loaded into the memory. This is the diagram which you have to make, like just make briefly. Okay, so algorithm, this you have to write for compulsory. Begin, end, in between we are performing a while loop, before that we are initializing some things. Is a begin and end, in between we have used while loop, and here we are initializing some things. It's very simple. First read the header record, verify the program name and length, read the first text record. The content which you are reading, there are many lines, each is called text record. Read the first text record, and if it's not empty, then if it's in object code, then move the object code to the specified location in memory, then repeat it. That's all. Take this, read it. If it's in the object code, transfer it into the memory, this memory here, and read the second one, transfer it into the memory unless it is empty. Then we will be coming out of it. That's what the algorithm for the absolute loader is. And there is a simple bootstrap loader. It gets loaded when the system is powered on, and there are some functions which are performed. So you can go through this. I already have explained in the video. So for more information, you can go through that. Okay. So that's all what is there in the module 1. Let's move on to the module 2. In the module 2, we totally have 7 questions, and among that the important ones I'll mark now. This one is important, and this one is important, and this one is important. I forgot to mark star here, but make sure you don't miss these 3 questions. Okay, so let's get started with the first one. Differentiate between compiler and interpreter. See, one word I will tell you. What is the compiler and interpreter? If this is the source program, compiler will do it all at once and interpreter will do it line by line. This is the first point which you need to write. After that, you can get many points here. You can search that and write. Okay, so I'll show you what are the points present here. It's in page number 7. So these are the points which are present here for the compiler and interpreter. The first is it translates the entire program in one go, and then it executes it. Interpreter does it line by line. Then we have a few more concepts, like which is more efficient and which is more for good for error reporting, and how much difficult it is to use, which object programming languages are using the compiler and interpreter approach. Those are the further points which you have to mention. Moving on to the second one, list and explain each phase of a compiler. Okay, there are totally 7 phases of compiler. It's very important question, and this same example they have repeated many times. Position is equal to initial plus rate into 60. There are 7 phases. You have to show the output of each phase for the expression. Okay, first you have to list, explain, and show the output. So let's see how to do that. So you'll list each of these phase. This is the first one, and then you will be explaining it, and then you will be showing the output as well. So the first, this is the equation which is given to us. Position is equal to initial plus rate into 60. And then what we will be doing, lexical analysis. Lexical analysis, what it will do, it will differentiate each of these into different tokens and assign some ID to it. So different IDs and tokens are present here. And syntax analysis will make it into a separate syntax tree, and these things are stored here. Means what does 1 represent? Position. 2 represents initial, 3 represents rate. So because we have written ID and comma 1, right? So what does it represent? Position. And then ID and 2, it represents initial, ID 3, and then 60 only here. So what are the variables that are present here? That is mentioned in the symbol table. That is the second phase. And the third phase is semantic analysis. It analyzes for the semantics errors, and then the intermediate code is generated, and it is getting more efficient in this step. After that, finally the final code will be generated, the assembly code. So these are the 7 phases. You have to draw and write the output as well as explain each phase. So this can fetch you 7 to 8 marks. A very important question from exam point of view. After that, we have the list and explain the different compiler construction tools. What are the different tools used in the compiler construction? Okay, so it's present at page number 5. So in page number 5, we have the compiler construction tools: parser generator, scanner generator, syntax directed translation, code generator, data flow analysis, compiler construction toolkits. Okay, this you have to write and explain what do these tools mean. Then we have the role of lexical analysis with a neat diagram. It's presented page number 18. Role of lexical analysis. What is the in-depth explanation regarding the lexical analysis, what it does and what are the different steps in it. Firstly, you have to write this diagram, and in the diagram you can find out 3 things: lexical analyzer, parser, and the symbol table. What happens is the source program comes from here, it goes into lexical analyzer, and each token is generated in the lexical analyzer. Every token one by one it goes to the parser, and both of these, lexical analyzer and the parser, refers the symbol table. And after that, when it is done, it will go to the semantic analysis, and it will fetch the next token from here. And the task of lexical analyzer is present here. You can go through it. Okay, that's all what you have to explain the role of lexical analysis. Then we have the defined tokens, patterns, and lexemes. These are the 3 definitions which you have to memorize. So okay, let's go to page number 19. There we have the definitions for token and patterns and lexemes. Token is just a pair consisting of token name and an optional attribute value, a name and value. Okay, so for example, I'll show you the example later. Pattern is just a pattern for fetching the means lexemes present. Okay, like for example, this is the pattern and this is the token name. For identifying we are using this one. Okay, lexeme is nothing but the logical sequence. It matches the pattern and it makes the logical sequence. So if it is keyword, if is a keyword, so pattern will be I and f under square brackets, and after that we have a lexeme as if. The actual word is nothing but lexeme. So this is the difference between the lexeme and token and pattern. Next we have the local two logical lexical error recovery options, input buffering and two buffer technique. Among these two, the input buffering is the most important one. So in input buffering, under this topic only two buffer technique also comes. Let's see what is that. So this is the logical means lexical error recovery options. So when error happens, what we have to do? We have to do either of these four things. So in doing these four things, we can use the technique which is input buffering. In that there are two single buffer technique and two buffer technique. Okay. In two buffer technique also there are two types, without sentinel and with sentinel. So I have to explain each of these concepts in detail. Okay. So there is a program also for that. You need not write the program, just the theory part will be sufficient for you. Then we have to write the lexical, draw the transition diagram and write the algorithm for relational operator, identify unsigned numbers, keywords and white spaces. These four are the most important, and along with that white space also there. It's very small topic, so you can go through that as well. So let's go to C25 and see what are the different transition diagrams. See what is the relational operator, less than, greater than, less than, equal to, greater than, equal to, not equal to. So for that we will start from here, make the automata for it 0 and less than. Less than can be either less than equal to or nothing or just not equal to, or it can be nothing, so it will be returning equal, or if it is something like greater, greater equal to, or nothing, just greater. So these are the different possibilities, and for that we will be returning the different values LE, LT, NE, Q, G and GT. Okay, same goes for the keyboard. There is a program here. If you get time, you can study this program and write. It will fetch you more marks. Else you can just write the transition diagram. That also you will get some marks for it. So you have the identify has the same thing goes for the keywords and unsigned numbers as well as for the white spaces. So quickly recapping, what are the things you need to focus more upon? These are the 7 questions which you need to focus totally, like for the whole module. And among these 7 questions, 3 questions which I mentioned, this one, lexical recovery options, then the transition diagram. These are the very important questions. You need not miss at these questions at any cost. First complete these 3 questions, then complete the rest of the questions. Okay, so that's all for the module 2. Let's move on to the module 3. Coming to module 3, we have mainly the problem types. So very few theory concepts are there, but whatever the theory concepts are there, let's discuss them. Okay, so the theory concepts are the what is the role of a parser, explain the different error recovery strategies. Okay, so let's see what is the solution for that. It's present in page number 7. So actually it's in the other PDF, but in this PDF also you can find it in the page number 2. It's starting from here. So the different types of errors are lexical errors, syntax errors, and the semantic errors and the logical errors. Okay, so these are the 4 type of errors which you can find in the programming. And in the lexical errors, it includes like the misspellings of identifiers. Like for example, instead of ellipse double L, we just wrote a single L. That is the lexical error. That's the first type of error. The second is the syntactic error. There we have the misplaced semicolon or extra braces, so some extra things we are adding, or you are missing some small things. And semantic errors is the logical, like it's like the logical error itself, like the return statement of Java, it is of the result void instead of having an int, because if you are returning an integer. That's the semantic errors. And the logical errors is instead of using equal to, you are using double equal to, like the logical errors. Okay, and there are error recovery techniques like the panic mode and the phrase mode, error mode and global mode. To give you a brief overview, panic mode is just the recovery of a single character. Phrase level recovery is the recovery of the whole phrase. Error predictions are like if the error happens, what is the prediction that is to be used to resolve the error, that will be defined. And global correction means there will be some global variables and the functions defined, so that whenever error happens, that will be called and the error will be resolved via those functions. Okay, those are the error recovery techniques. So that was the one of the theory questions. And the second is the okay, so these are the problem types, all are the problem types, and in between you can just find out few of them which are theory. So mainly all of these I have discussed separately as a separate topic in my previous video. So in this video I'll be just giving you a brief overview of each of these concepts. So LMD, RMD, parse tree and ambiguity. So what you can expect is, let's see the page number 6 here. There you can observe. Okay, so in page number 6 we have the question type, like this is one of the important questions, like give the LMD and RMD for the string as well as the parse tree, and we have to say if the grammar is ambiguous or unambiguous. 4 things we have to do. So we'll be given with this grammar rules, and this is the input here. For this input we have to parse and do the LMD and RMD, and we'll get separate parse trees, and the grammar is unambiguous because only it has one LMD and one RMD. That's all what you have to do. You can easily get 8 marks for it, 2 marks for each of these steps. And the next one is eliminating ambiguity. How to eliminate ambiguity? There are 2 rules: disambiguity and using precedence, and associativity rules. Okay, so it's present in which page? 16th page. Okay, so let's go to 16th page. So here we have 2 rules: disambiguity rule and using precedence and associativity of the operator. Precedence and associativity, it's very simple. It means that if there is an ambiguity, like we have to choose into or plus, at that time we'll be using into because it has more precedence and associativity, right? Disambiguity means if we have 2 else conditions. For example, if this is the grammar which is given to us, and we have the input string as this one, this is the input string which is given to us. So here what we have is, at the last part, as you can see, else if stands for else, and A stands for other statement, B stands for other statement. After this else is encountered, whether we should take A or whether we should take B, that's the ambiguity. So for resolving that, what we will be doing is, we will be using the first condition. Like there is a rule that you will be using the first phrase that associates else with the second condition. Whatever is in the first phrase, that will be taken, or we can define C as B separately also. Okay, so here some rules are given, and this I explained in detail in the theory video, so you can go through that. And the second option is the eliminating ambiguity using precedence and associativity. So here you will be having a table where you will be having the associativity and the precedence, which should be considered first, which could be considered second, which should be considered third. Okay, by using that also you can resolve the ambiguity. Next we have left recursion and indirect left recursion. So indirect left recursion, I can give you an example. For example, if we have like S goes to A beta, okay, and A goes to S gamma or alpha, like that. If it is there, what we have supposed to do is, we have to replace this with here. What happens here, if you observe carefully, what's happening here is S goes to A, again A goes to S, again S goes to A, again A goes to S, like that it will keep on happening. So to avoid that, what we will be doing is, S goes to it was A beta, and here it was A goes to S gamma and alpha, right? What we will be doing is, A beta will be substituting in the place of S. So what we will have is A beta gamma or alpha. Here it is just direct left recursion. Now how to resolve direct left recursion, that I will be explaining. So to resolve direct left recursion and then left factoring, top down, and this is just the theory concept. Top down parsing. What is top down parsing? From top to down we are parsing, that is called as top down parsing. Recursive descent parsing problems. Here we have the questions given to us, and we have to write the means the algorithm for the recursive descent parsing, and that is explained in my module 3 video. So in the notes it's not properly mentioned, so you have to refer that only. First and follow LL of 1. LL of 1 is very important. All of these steps are to be performed to get the LL of 1 table. Okay, then we have finally the shift reduce parsing and the bottom up parsing, which is nothing but shift reduce parsing. Here we have some theory, means the numerical here. Okay, so let's get started with the left recursion. It's presented E25. So in the 25 page we are starting from the left recursion. So to eliminate the left recursion, we will be using this formula. Okay, and indirect left recursion is also eliminated, as I told you how it is eliminated. And this is left factoring. You will be using in this way to eliminate the left factoring. In the left factoring, what you will have is the different terms will be taken as common, and the remaining terms will be written in the other way, in the other line. Okay, that is left factoring. And top down parser is by from the top you are starting and parsing down in the bottom way. And here is the example for the recursive descent that I explained in that video, so you can refer that. And what else is important is first and follow, then LL of 1. That's all. First and follow and the LL of 1. So first and follow, here you have to make a table, and you have to start from the bottom. This I cannot explain like this orally, you have to refer that video only. From the bottom you have to go, and you have to traverse each of these and write what is first, and then you have to write what is follow for each of these symbols, and by using that you will be writing the predictive parsing table, and then you will be writing LL of 1. Okay, so here many questions are there. If you watch that video once, and you will get to know what is the logic and how to solve that, and then you can come back here from the page number 25 and you can start solving, and that will be good for your preparation, right? So yeah, that's all what is there in the top down parsing. And coming to the bottom up parsing, that is also known as shift reduce parsing. Here you will be given a question, you have to make the stack input and action, and you have to do the following what is present here. Okay, this also I had explained, you can go through that. Make sure you never miss any of these concepts. These are very important concepts. And yeah, that's all what is there in the more important in the module 3. Let's move on to module 4. Module 4 is the pure theory module, so you need not have much thing to understand here. You just have to keep in mind the important concepts and you have to write. And there are many important questions from this module. Easily it's predictable, like what are the important questions, because they have been repeated a lot number of times. So in this video, whatever I have marked with star, that is the important concept. So there are many important questions, you cannot miss any of them here. So let's get started. All you need is this PPT, and that will be more than sufficient for you. So if you are not referring the textbook, that's also fine, because this PPT has the important concepts, so you can go through here. And what are the page numbers I have mentioned here, you have to refer those page numbers and keep the concepts in mind. Okay, the first question is explain the structure of LEX and YACC program. Very important concept, and LEX is the more important one among these two, with an example. Okay, F8 and F20 means 8th page and the 20th page. So let's see what is the structure of LEX program. So in page number 8 we can see the structure of LEX program. YACC program is also same, just slight difference will be there. Here the definition section, rule section, user subroutine section will be there. So the information regarding each of this is given here. The rule section, we will be defining the logic and the rules here, and after that we have the user defined section, user subroutine section. Here we will be writing the main function YY wrap or YY error as well. So these functions are written here, and one thing the difference between LEX and YACC is that in LEX you will be using YYLEX, and in YACC you will be using YYParse. Okay. The next question is regarding the identifying the part of speech. It's present in page number 7. So the part of speech program, this is also a repeated one. So basically here what's happening is, here you will be having the means there is no definition section, because no variables are used. Here you are defining the logic, you are defining multiple words here. If the word gets matched, what you have to do, that is getting defined here. In main function, just YYLEX. Only if you write this one, you can easily score 8 marks, right? So that was about the LEX program. And then we have the symbol table. What is a symbol table? Let's see, it is in page number 18. So in page number 18, it's defined as what is a symbol table. Here we will be storing the tokens and the IDs. Okay, and we'll be using an add word or a lookup word to add a new word or check the existing word. So that's what the symbol table is, and here is the program given as well as an example for it. So if you have time, you can write the example, or else the theory will be what you will be writing in the exam. And explain the Lexer-Parser communication, a very important question. It's in page number 24. So Lexer-Parser communication, how do the Lexer and Parser communicate with each other? What are the different tokens getting exchanged? And when they are referring the symbol table, those are the things which is defined here. And yeah, these are 2 pages basically what you have to go through. So you'll get the concept what you have to write. Okay. And what is a regular expression? Here you have to define the symbols as well. It's present in page number 40. So let's go to page number 40. So here are the regular expressions, and for the different symbols, at least you have to write 5 symbols. So many symbols are present here, as well as the examples are given, so you can go through it and keep some of them in mind. Okay. So yeah, that's all what is there in the regular expression. And word count program, lab program 1, 2 and 6. Never miss these programs, it's repeated concepts. So word program, I will give you a brief overview. Lab programs I have already discussed, so I will not touch on that. And I will be just discussing the word count program. It's present in page number 46. So let me tell you what all you have to write. You have to start from here. This is the definition section, and first write the whole program, then you can write the explanation of it. Then this is the rule section, and this is the user subroutine section. These 3 codes you have to write below each other. Okay. After that, if you want, you can explain what is the points given, so that can fit you an extra 3 or 4 marks. Okay. The next one is the explain the grammar and how ambiguity is eliminated. Take an example of 2 plus 3 into 4. This is the same question which is repeated many times. Okay, so let's see what is there. F76. So in 76 page number, you can see arithmetic expression and ambiguity. So yeah, it's starting from here. So what is ambiguity? You can have multiple possibilities of performing the operation, like for example 2 plus 3 into 4 is written, right? First you can either do 2 plus 3 into 4 you can do first, or you can do 2 plus 3 first and then into 4. These two possibilities are there. How to resolve this possibilities? By using the precedence rules or disambiguity rule. Okay, so here I got the precedence and associativity is given. You can go to this as well. And implicit and explicit associativity, one is the inbuilt, other you are specifying it separately in this case. So both the options are possible. About that only you have to write how it is eliminated. Then yeah, this one is also part of the previous question. What is shift reduce parsing, recursive rules, and lex and handwritten lexer? This you can easily get in the Google itself. And recursive rules and shift reduce parsing I will be discussing. 63 and 61. 63. And what is a recursive rule? A recursive rule means the same rule is getting called again and again. For example, if I take the example of this one, expression number, and expression can be defined as expression plus number. Again expression comes here, it can be defined as number, expression plus number, expression minus number. Again their expressions will come, that can be defined as number, expression plus number, expression minus number. So this rule is defined in a recursive manner, therefore it is called as recursive rule. Write what it means and the example for it. That was about the recursive rule. And we have shift reduce parsing. Shift reduce parsing will be doing two things, either shifting or reducing. Reducing means if a expression is given like a is equal to b plus c, and in the program we encounter b plus c, you are writing b plus c as a, so I'll be writing it as a, that is the reducing. Shifting means if I don't have any operation, I'll be shifting the next input value into the stack. Okay, that is shifting. More information is given here as well as I've explained in the video, you can go through it. Okay, so yeah, that's all what is there in the module 4. Let's move on to the next module, module 5. Here also the many things are there, because it is a numerical module. So here we don't have much theory part, but some of the theory parts which are present are the synthesized versus inherited attribute, differentiate between SDD and L-SDD, and issues in code generation. Never miss this topic. Okay, issues in code generation. So these are the three topics which you have to never miss in the module 5. So let's get started. And I'll be explaining module 5 in some depth, because in the theory video I have not explained it properly because the annotation was not there and I was not aware of it. So let's get started with module 5. In the module 5 also I am referring the MEMS notes only. So okay, so this is the module 5, and the first thing you need to know is the difference between the syntax directed translation, means the synthesized attribute, and inherited attribute. Synthesized means it's a direct attribute, there is a direct relation given, and by that you are deriving the attribute, that is synthesized attribute. Inherited attribute means either you are taking from the parent or from the siblings. Okay, synthesized means there is a direct relation between the node and the child node. Inherited means either you are taking from the sibling or from the parent, okay, or both. This is what you have to write like a diagram, and you have to explain it in the theoretical manner as it's present here. Okay, that is the first question, synthesized and inherited attribute. Differentiate between SDD and L-SDD. SDD and L-SDD is this one. S-SDD, S-attributed SDD, and L-attributed SDD. The important one is the S-attributed SDD. We have the numericals on that as well. Okay, so it's present here. It's using the bottom-up approach. In the L-SDD, it is using the top-down approach. Okay, and this is the table which you have to make if they ask you the definition. Okay, then we have the problems on SDD, DAG and quadruples, triples, and Indirect Triples Three-address code, syntax tree, static single assignment. For this one question is there, and for DAG also I will discuss one question. Problem SDD 1 question, and instruction code generation 2 or 3 questions, cost of program 3 questions. Okay, so and after that there is issues in code generation. Let's get over with that. So it's in page number 57. Let's do it first. So what are the issues in code generation? You can easily go through 5 minutes. You can easily memorize as well. So input to the code generation, target program, instruction selection, register allocation, evaluation order. Okay, so the input to the code generator, that is one of the concepts which is taken into consideration while designing the generator. Target program, what is the output of the program, whether you are using which architecture. This I have explained in detail in the theory video, so I am not focusing much on this here. Instruction selection, register allocation, what type of register you are using, specific or general. Evaluation order, in which order you are evaluating, that also matters a lot, because sometimes the redundant code gets evaluated, means it takes more time. So if you evaluate in a different order, it will take less time. Okay. So yeah, that was the theory, three theory topics from the module 5 which are important. And then we can get started with the problems. There are two problems here. Okay, first we will get done with the instruction code generation, cost of program instruction. Okay, so because these are closely related to where I was. Yeah, this is the 3-address code generation for the statement present here. So first what we are doing, we are loading R1 y into R1, then we are doing the subtraction operation after doing the loading of z into R2, and we are actually not adding, we are doing subtraction, so it should be written subtraction here, and then R1 R2, and that will be storing in R1 and will be using the value of R1 in X. So that's all what is present here. You have to do it step by step way. Here many questions are there. If you are using the pointers, first you have to load the p value in R1, and then you have to use the O means contents plus the means wherever you are present, that content you are retrieving and that you are storing in R2. Because see, what does a pointer mean? A pointer means you will be having some value here and you will be having a pointer q which will be having the address of p. Okay, so what is present in p, that should be fetched, right? So firstly you are referring what is present in R1, that is fetched and stored in R2. Okay, then you are storing the value of R2 in X because X is equal to the value present here. So like that only you can go through these questions here. If you have any doubt, you can text me in the Instagram. My ID is given in the description box, so you can practice as many questions as you can. And next is the instruction cost. Okay, in instruction cost, these are the different types of addressing and the different costs associated with that. This I will explain in detail in the previous video. So here the cost associated, you just have to see the cost and write down the means for which operation how much cost is getting executed. Okay, so you'll be using that formula, and for each you will be having to you will have to add one, and what is the cost associated, seeing in the table you have to write it here, add up and write the answers here, and then finally find the total cost. Okay, so these are two types of questions which are present at the last of this module. And if we come to the main part, here we have the quadruples, triples, indirect triples. Here one question is there that should be sufficient for you, so you can easily get to understand what is that. So it's presented page number 45. So actually from 45 it is starting. Actually from this you have to also write the theory part as well. So I have written page number 45. 3-address code is built on the concept of address, and three things will be used. Like for example, here we will be having a operation to be performed. Here we will be having the operator and the second operand. Okay, this is the operator and the operand. So this is known as 3-address code. So here some theoretical concepts are given. So this only you have to write in the exam as well. And if you know the to solve the problem, you can easily write the 3-address code. And the quadruples are present. Quadruples mean there will be 4 things here. Operator means operand, and between the operator will be there. Okay, that is the quadruples. And the basic difference between the quadruples and the triples, so the next one is the triples as well. So here we are having just 3 columns: operator, argument 1, argument 2. This only I mentioned. This is the operator, operand 1 and operand 2. Okay, each step what we will be doing, we will be writing here. Okay, and this is the same question which is getting repeated many number of times. Okay, so make sure you go through this and practice the same question here. And that was about the triples. And indirect triples are also same, but just you will be writing the instructions and means whatever the values are present here, that values will be taken in a separate table. That's all what you are doing, nothing else. That's the same thing which you are doing. Static single assignment form is also the same thing here, just you will be having a different denotions for the variables. For example, instead of just taking p here, if p is getting the value changed, you will take that value as p2 instead of just re-updating the same variable. That's the only difference between 3-address code and static single assignment. And here's the question. Okay, if you practice this question carefully, it's sufficient for you. All the things are covered here. Okay, so let's solve this one. B plus c, and here a is there, my plus and minus b plus c. So first what you are doing, b plus c is there, right? So b plus c is taken from here, and that is getting plus, and the whole thing is getting minus here, and that is getting added with a. So that's how you make the syntax tree. In T1 you will take b plus c, T2 is minus T1, then minus T1 is getting added with a, that you will be storing in T3. That's how you write the syntax tree. After that we have the quadruples. In quadruples you will be making 4 columns. Quad means 4, triple means 3. So 4 columns you will be making, and the result you will be storing here, and that result you will be using in a next iteration. But here instead of using the result, you will not make any result here. instead of that 0 1 2 only will be used, like 0 1 and 2. Okay, and the indirect triples, and same thing, you'll be writing a copy paste the same thing here, no difference, just 0 1 2 will be making a separate table here. That's the indirect tuples. And yeah, that's all what is there. And static single assignment, they'll not ask, they are not asked much in the exam, so you can skip that for now. And yeah, basically that's what is there in the quadruple, triple and single assignment. Here's another important question, so that's also the same thing. So if you go through this, you can easily understand what we are trying to do. See, after writing the 3-address code, you know how to write the 3-address code, right? After that, what you will be doing is you will be storing these values in P1, and again when you use P, just write it as P2. That's all what your difference what you are making. Okay, so do one thing, watch the previous watch this video first and then go to the theory video. In that annotation is not there, but here I am explaining with the annotation briefly. So if you go there and listen carefully, you can easily get to know what I am trying to say. Okay, so I hope that should help you prepare for the externals. And one more thing, what is left is the DAG, and using the DAG for the S-SDD. So in S-SDD also you will be doing the same thing, and you will be having 4 things here. So DAG, let me explain it, page number 48. Sorry, not 48. Yeah, this is the DAG. So I'll be explaining what I meant in the theory video. See here, this is the expression which I have been given with. First you will be writing A and B. Okay, then what you are doing, plus operation here, so I will be writing plus here. Then the same thing is getting added if you observe carefully. A plus B is again getting added with the same thing. So this is what A plus B. So if I take it like this, it will be A plus B here, and if I take it like this, again it will be A plus B here. So A plus B and A plus B is getting connected with again plus, so it will be A plus B plus A plus B. That's what the question is. That's how you solve the DAG. For all the next questions also you will be doing the same thing here. And to write this table, what you will be doing is 1 ID and 2 ID. What is the unique things you will be writing here, and assigning some ID values. You will be using these ID values for the next further iterations. So 1 plus 2 will be stored in 3. What is 1 plus 2 mean? A plus B. So 3 is nothing but A plus B. So 4 is nothing but 3 plus 3, right? 3 plus 3. What does 3 plus 3 denote? A plus B plus A plus B. Okay, that's how you write the DAG. If you know how to write the DAG, we can move ahead with the problems on SDD, S-SDD, G8. So let's go to the page number 8. Okay, so the important question here is, as I have discussed in the previous video as well, so this was the important question. So here is the input which is given to us. First you have to write this one. This is like how it is, you have to write, you have to by heart it, and annotated parse tree. Okay, how to write this one is, firstly you will be calculating the value of this one. Okay, 3 into 5 15, 15 plus 4 19, and you will take it as 1. Okay, so first start from 19, then it is divided into 2 parts. E dot val is equal to 19 and n. Okay, so start from here, the left part, separate n and separate this whole part. N is taken separate and this answer is taken separate. The answer is written as E dot val. Then the E dot val is also separated here. How it is separated? Like this. E dot val, 3 into 5 is taken as separate and 4 is taken as separate. Okay, so 4 is taken as separate, E dot val is taken as separate, the remaining expression value, and plus is taken in middle. Again you will keep on dividing these ones. Right, when you keep on dividing it, if you have the multiplication, you will be using T into F. If you have the addition, you will be using E plus T. That rules are defined here. So first you have to write these rules. If it is addition, you will be using E plus T. If it is multiplication, you will be using T into F. Okay, and yes, this I had explained in depth, and what I meant was like the annotation part has been missed. So that's what I am trying to mention here. If it is multiplication, you will be using this one. If it is addition, you will be using this one. Okay. Then we have the DAG. DAG you know how to write. Start from the last part here. When you reach here, start from here 1 2 3, then 4 5, then again you will be starting from here 6 7 8 9 10 11 12, like that. Okay, so in the same way, if you do, you can write this part here, the dependency graph. After that you will be just writing 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so SDD is like, if the question is asked, SDD is repeated 90% of the times, L-SDD is repeated only 10% of the times. So I am just focusing on this one. Okay, even I am not studying L-SDD for exams. Okay, so if the question comes from SDD, you will be able to write, else you will go to the OR question. Okay, because actually L-SDD is not that easy, it's very hard and it will take a lot of time to understand that. Instead of that, you can study some other important concepts, right? So relatively that will fetch you more marks, like skipping L-SDD and studying some other concept in that time. Here's another question which you can practice for SDD. So how many questions are there for SDD? Practice all of them. If at any time you get doubt, you put me a text on Instagram, and my ID is given in the description box. So yeah, that's all for this video. If you want more videos like this, and if you like this video, hit the like button and subscribe to my channel, and thank you so much for watching. I'll see you in the next one.